Hello everyone. In this episode, what we are going to be talking about is a subject called control structures. This is actually a subject that I've been looking forward to getting to for quite a while, because control structures will greatly increase the power and flexibility of what we're able to do with the scripts that we're writing here in JavaScript. More or less what control structures are is they are bits of code that we can insert into our scripts that will allow us to control the flow of execution through that script. So more or less, as opposed to the scripts that we've been writing so far, which pretty much just execute from beginning to end, statement after statement, without anything really changing that flow, control structures will let us add a lot of variability to how everything actually works. We'll have control structures, for example, that will let us decide whether to execute one group of statements or a different group of statements depending on conditions. We'll have control structures that will let us have repetition or loops that occur within our program. All kinds of wonderful things that will really increase the range of what we're able to create. The way control structures are actually written in JavaScript, for the most part anyway, is that they typically start off with some keyword. And the keyword is what tells JavaScript exactly which control structure it is that we're actually using. That keyword is then typically followed by a set of parentheses that has inside of it some type of test. Now the test itself is some expression that produces a Boolean value, something that's going to be true or false, or have truthiness or falsiness, if you want to think of it that way. That's usually what's going to then control the actual control structure itself. Following the parentheses, we then have a set of curly braces. The curly braces are usually called the body of the control structure, kind of like we have the body of a function inside curly braces. And everything that's inside those curly braces are then the statements that the control structure is actually going to more or less be in control of, that it's going to affect in one way or another. There are really three types of control structures. There's the sequence structure, the selection structure, and the repetition structure, although I've also thrown in a fourth type here called special to accommodate one special thing that JavaScript has that you don't run into in most languages. The first of all of these different types of control structures is the one called the sequence structure. A lot of times I call this the no structure structure, because the sequence structure is actually sort of a built-in automatic thing. It's actually the control structure that we've been using all along without even really realizing what it was. The way the sequence structure works is that it simply forces statements to execute in the order that they're written. So if statements are written into your code, statement A, statement B, statement C, that's exactly the order that they will execute in. So there's no special keywords that have to be used, no special anything that has to go on into the code. It's simply the thing that we've basically been doing all along. Sequence structure is one that you use all the time, and since it's so simple, a lot of times we do it without even thinking about it. You know, for example, maybe we have a script, print out the word hello, followed by followed by printing out the word world, followed by an exclamation point. Those three statements written in that order would simply print out hello, then world, then exclamation point. And obviously that's not valid JavaScript code, that's just shorthand here for these little flowcharts. The next type of structure, the first one we really need to talk about because it's not something that we've really done before, is called a selection structure. A selection structure is basically some type of test which will then let the script decide whether to execute statements or not, whether to execute one group of statements or another. Basically, it lets the program act sort of pseudo-intelligently and make a decision. Should I do this or not? Should I do this or should I do another thing? So in a selection structure, we always have some Boolean condition that's used to determine if a statement or group of statements should be executed or not. There are a couple of different types of selection structures, a pretty good variety of them available in JavaScript. We'll talk about if statements, if-else statements, switch case statements, quite a few different ways that we'll be able to put together selection structures. Like I said, selection structures do come in a variety of different flavors, you might say. For example, a single selection structure would be one where the script simply decides, should I execute a statement or statements or not? So there would be some test. If that test is true, some statement or group of statements gets executed. If the test was false, then that statement or statements would not be executed. An example of a selection structure here would be something like where we say if the value of a total variable is greater than 1,000, then maybe we set a variable called shipping rate to discount. Just one of a million different places where we might use that type of structure. Another type of selection structure is called a double selection structure. This would be one where the test decides between two groups of statements which ones to execute. So the test would still be a Boolean condition, and if that Boolean condition evaluates to true, then one group of statements would execute. If it evaluates to false, then it would be a different group of statements that executes. For example, if a username variable is equal to admin, then we maybe set a logged in variable to true. But if the username variable is not equal to admin, then maybe what we do is we redirect the user to the login page, something along those lines. Another interesting variation of selection statements is that we can have what are called nested selection statements. That's basically where one selection then feeds into another selection. So one test is performed. If that test is found to be either true or false, then maybe another test is performed. So here in this little diagram, test A is evaluated first. If test A is true, then we go on and we perform test B. If test B is true, then we go on and execute statement 1. If either test A or test B are false, then we go and we execute some other statements somewhere else that do something else. So nesting can be quite an interesting little subject too. So now let's go ahead and take a look at some of the actual code that will let us create selection structures and see some different examples of things that we can do with them. Basically, the way an if statement works is, well, let me start here by putting in some script tags in the body. Basically, the way an if statement works is we start with the keyword if, followed by a set of parentheses. Those parentheses are then typically followed by a set of curly braces, although the curly braces are not strictly required, as I'll show you here in a second. The way the if statement is actually going to work is here inside the parentheses we are going to need to put in some expression that produces a Boolean value, something that can be seen as either being true or false. If whatever is here inside the parentheses is seen as being true, then JavaScript will execute whatever statements are here inside the if's body. If whatever's inside the parentheses is seen as being false, then JavaScript simply will not execute whatever's there inside the if's body. So let's do this. Let's create a variable. I'm going to call it input, and to get the input, I'm going to prompt the user to enter a number. There we go. And then down here in the if statement, just for example's sake, let's say if input is greater than 10, then do a document.writeLine and print that's a big number. Something simple quite like that. So let me hop over to my web browser and hit refresh. It asks me to enter a number. If I enter the number 11, I get my document.writeLine. That's a big number. If I hit refresh and put in the number 3, you can see I don't get any output at all. So what's actually, of course, happening here is we take our input from the prompt. We then check to see if the input is greater than 10. If that statement is true, if it's true that the value of the input variable is greater than 10, then of course it prints out our document.writeLine. Whereas if the value of input is not greater than 10, if that's basically a false expression, then we do not get the document.writeLine. And that's really about all there is to it. With a simple if statement, a single selection if statement like we have here, our tests can of course be a bit more complicated. I could, for example, say if input is greater than 1 and input is less than 10, or maybe we'll say less than 11, then I have a slightly more complex expression, a slightly more complex test that's being done there, but overall this expression will still produce a true or false value. As long as I enter a number that is both greater than 1 and less than 11, this will be seen as being true and our document.writeLine will print. Let's give it a try. So let me put in the number 0. No output, so the if statement saw that expression as being false. If I put in the number 5, 5 is both greater than 1 and less than 11, so that is true, and it gave us our document.writeLine. If I put in the number 34, that of course makes the expression false. So if statements are quite simply just that. There's really not a whole lot more to them than than what exactly I have there. Can be very handy though. They can let your program make decisions about exactly what action should be carried out. All right. Oh, the one other thing I wanted to show you about these simple if statements is about the curly braces and the fact that they may or may not be required. Let's just, for example's sake, put in another document.writeLine here. All right. And I'll have it say, let's see, your number was, and then I'll have it print out the value of input. There we go. All right, with everything like it is right now, right, everything should keep working just the way it was. If I put in the number 5, I get both document.writelines. If I put in the number 0, nothing. If I put in the number 90, nothing. So pretty much just what you'd expect. In this particular case, the if statement is controlling the execution of both of the document.writelines. Now, if I take out the curly braces, things are actually going to change a little bit. This is a pretty common mistake. And basically what happens is that the if statement actually only controls whatever immediately follows it. When the curly braces were there, like that, then what the if statement is actually controlling is the entire block of code, basically everything from the first curly brace to the last. But if those curly braces are taken out, then the if statement is actually only controlling the very next statement, the thing that immediately follows it, which is the first document.writeLine. If we take a look at that in the browser, we can see the behavior that changes. If I put in the number 5, it looks like everything's still working just fine. If I put in the number 0 though, you can see that I only get the second document.writeLine. Same thing if I put in something like the number 90. So despite my indentations that sort of make it look like the fact that both of these document.writelines belong to this if statement, in actuality the if statement at this point without the curly braces is only controlling the document.writeline that immediately follows it. If I want the if statement to ever control more than just a single statement, I have to put in those curly braces. Some people like to leave the curly braces out in situations where the if statement is only controlling one statement. But I usually go ahead and put the curly braces in anyway, because from my experience what often happens is what's one statement now may become multiple statements later. And if later you forget to come back and put those curly braces in, you'll have some strange sort of logic problems in your script that might be a little bit hard for you to track down if you're not thinking about what it could be. So anyway, that's a pretty straightforward, simple if statement, a single selection if. Let's go on down here then and look at a double selection if. The way a double selection if works is it starts off exactly like the single selection if, but the last curly brace is then followed by the keyword else. Right? What we actually then have is basically an if statement with two sections. We'll still have a Boolean expression here inside the parentheses. If that Boolean expression is true, then whatever's here after the if statement inside the first set of curly braces will still execute. But if that Boolean expression evaluates to false, what will now happen is whatever's down here inside the else portion of the structure will actually execute. So what makes this, of course, different than our first if statement was that our first if statement simply said what to do if it's true. This if statement says what to do if it's true and what to do if it's false. So I could say something like if input is greater than 10, then do a document.writeLine and say that number is greater than 10, right? Down here in the else, if the number is not greater than 10, then we could do a different document.writeLine, for example, where we could say that number is not greater than 10. All right, so let me go ahead and run that. All right, if I put in the number 4, right, I get that's a big number because it was my first if statement. It is between 1 and 11, but then I also get that is not greater than 10. So what actually happened there, if we skip over the first if statement, is here JavaScript checked to see if the input, which was the number 4, was greater than 10. In that case, that was false. It was not greater than 10. So it came down and it executed the else section of the if statement, what I a lot of times call the false section. So we ended up getting that number is not greater than 10 printed out. Right? If I come over and I run it again and I put in the number 89, right, it tells me that number is greater than 10. So here 89 is greater than 10, so it executed what I would call the true section of the if statement. Right? So that would be called a double selection if statement. There's lots of good things that we'll be able to do with that too. Right? One of the third things that we can do with if statements is called nesting. Nesting an if statement is simply where we put an if or an if else inside another if or if else. So we could do something like, say, if input is greater than 10, then next check to see if input is greater than 100. Right? Something along those lines. So of course the way the logic of this works is we first check the first if statement. Right? If that's true, then we come inside here and we would then check the second if statement. If that's true, we would then execute whatever code lives right here. So document.writeLine, that number's bigger than 100, for example. Right? Either of these ifs could potentially have else's that go along with them. So I could say document.writeLine here, that number's not bigger than 100. Right? Maybe another else to go along with the outer if I feel that the logic of the program needs it. Document.writeLine, that number's not greater than 10. Okay, so at this point we have three possible outcomes from this little segment of code. If the number is not greater than 10, then we go straight down to the else that goes along with that if statement, and we'll print out that number's not greater than 10. If the number is greater than 10, then we'll next check to see if it's greater than 100. If it is greater than 100, we'll of course print out that number's bigger than 100. Okay. If the number is greater than 10 but not greater than 100, then we will print out that number's not bigger than 100. Right? So actually, before I run that, let me put some breaks in these outputs up here so that things will be readable when we see it in our browser. So let's say I put in 4. Okay, that number's not greater than 10. The very last line I have there is from my nested if statements. If I put in 90, right, that number's not bigger than 100. And if I put in 101, that number's bigger than 100. So all the possible outcomes are there. One additional thing I might just mention to you here, at this point where we start having this sort of branching logic in our programs, keep in mind when you're testing your script to make sure that it works, make sure you test all possible outcomes, all the different ways that the script could potentially go. In the case of a single selection if, like we have up here, test what happens if the if is true, what if it's false. Same basic thing here for a double selection if. Make sure you test what happens if it's true, what happens if it's false. When you start getting into nested ifs, then of course you have to test the truth and the false of the outer if and the inner if. And with the nested ifs, they could be nested quite a bit more deeply than that. We could actually put as many ifs inside other ifs as the logic of our program happened to require. JavaScript doesn't impose any limit on how deeply you can nest ifs. I might also mention the importance at this point of the indentations. The way that I'm actually indenting different parts of my code is going to make it much easier to read, much easier to debug and understand. Really, it's a very simple little system. Anytime you go inside a set of curly braces, indent another level from where you would have indented before. As long as you do that, it makes things quite a bit more obvious that this if, for example, goes with this else, and that that's the closing curly brace for it. That this particular if then goes with this else, and this is the closing curly brace for it. So if you left justify everything, or if you're not consistent with your indentations, it can make things quite a bit harder to read. There's a much greater chance you're going to start losing curly braces and dealing with lots of funny little syntax errors that'll take up a lot of your time trying to track them down. Now that we've seen the basics of how if statements are put together, let's use some if statements to put together a little guessing game. More or less the way that I want this little script to work is I want it to come up and prompt the user. And when it prompts the user should have an opportunity to guess the secret number. It's an exciting game, I know. What we'll then want to do is we'll want to have the script first of all determine whether the number the user entered is the secret number or not. And as sort of a secondary part, what we could actually have it do, again using if statements, is we could have it tell them whether they guessed too high or whether they guessed too low. So what I'm going to do here inside this this new page is I've already put a set of script tags inside the body section. I'm going to start by defining a variable. I'm going to call it secret, and this is going to be the secret number that I want the user to guess. So I'm going to set my secret to 9. If we wanted this game to be a little bit more interesting, a little bit more challenging, we could actually put a random number in there, since anybody who could pull up this page's code, which would be basically anybody, would then be able to see what the secret number was. It would be much more interesting if we had a random number, but we'll wait until after we've talked about loops to do that. So what I'm going to do next then is I'm going to create another new variable. I'm going to call it guess, and I'm going to prompt the user guess the secret number. All right. So the user is going to have an opportunity there to type in whatever their guess happens to be, and what I can then do is I can use if statements to determine whether they guessed it correctly. So I could say if guess is equal to secret, okay, then maybe I'll do a document.writeLine. Maybe I'll print out a set of H1s, and I'll print out you guessed it, something like that. I could of course also put an else in here, right? The else would be what would happen if guess is not equal to secret number. So maybe in here I'll put in sorry, try again. All right, so that ought to do the trick and let our user make some guesses. So let's pull it up in the browser and see. Guess the secret number, 3. Sorry, try again. I'll hit refresh. Guess the secret number, 10. Sorry, try again. Oh my goodness, what could it be? How about 9? Oh, I guessed it. Good for me. I feel like I've really accomplished something today. So anyway, with just one simple little if-else statement, we can have a simple little guessing game here. Now, like I mentioned, if we also wanted the script to also at that point let them know whether they guessed too high or too low, what I could do is maybe here in the else section, instead of doing this document.writeLine, I could at that point actually put in another if-else. There we go. What I'm going to do with this if-else is I'm going to say if their guess is greater than secret, if the number they entered is larger than our secret number, then I'll do a document.writeLine and I'll print out you guessed too high. All right. Down here in the else section, document.writeLine, you guessed too low. There we go. Now you might notice here in the logic, the way this works is I'm not actually ever checking to see if their guess was lower than the secret number, smaller than the secret number, because by the time we get down here to this statement where we print out that you guessed too low, that should be the only possible outcome at that point. You see, if the guess is equal to the secret number, then we print out this document.writeLine and we skip everything else. All the rest of this is just skipped, so none of that will happen. If the guess is not equal to the secret number, then we come down to the else, right? And we check to see if the guess is greater than secret. And of course, if it is, we print out that they guessed too high. Right? Now at that point, if guess is not greater than secret, then when we know it's not greater than secret, we also know that it's not equal to secret, because we got to that this sort of else section here on the first outer if, which means when we get down here to this last nested if, the only other option that should be available is that the number was too low. So let's give it a try and see if it works. Guess a secret number, 1. You guessed too low. Secret number 10, too high. Secret number 9, you guessed it. So like I mentioned before, you'll notice there that when I was testing it out, I went through all the possible combinations, something you should always do. And that's just a real simple little example. What we could do to make this a little bit more fun would be, of course, to be able to provide the user with the opportunity to put in multiple guesses, to guess more than once, which is something we'll be able to do pretty easily when we talk about loops here in a little while. The next selection structure I want to show you is called a switch statement. The switch statement is a selection structure, so it's closely related to an if statement, if-else type statements. The difference is the switch is much more specialized. It's something that would be used in a particular situation when a particular pattern of tests need to be performed. And the switch statement is never strictly necessary. That's not that there's any particular type of program or any particular type of logic that relies entirely on you being able to use a switch. What it really is more than anything else is a convenience. Anything we could do with a switch, we could do with ifs and elses just as well. It just might be a lot messier and a lot longer to do so. For example, let's say that I had a script and what I wanted it to do was to take the name of a month, or maybe just to make things simple, we could do the numeric representation of a month, like 1 for January, 2 for February, so on and so forth. We wanted it to take that as its input, and then depending on what month was entered or what month was selected, we wanted it to perform some different behaviors. Maybe it was applying a different style sheet to the website for the different seasons, or something along those lines. What we'll do with ours, though, is we'll just have it print out a document.writeline. But that's certainly something that could be done simply with if statements. For example, if I had var, I create a variable called month. I'm going to prompt the user, enter a month. All right. If I wanted the script to do different things for different months, I could say if month is equal to 1, right? Then do something for month 1, document.writeline. I'm going to do a little copy and pasting here because we're going to do a lot of typing in this one. Maybe I'll just have it print out the abbreviation of the month, January. Okay. I could then say if it wasn't 1, then check to see if month was equal to 2. Okay. If it was, then let's print out February. Oop, not Reb, Feb. There we go. If it wasn't 2, right, then we could go on and have it check to see if month was equal to 3. I think you see where this is probably going by now. There we go. All right, if it's not 3, then we could have it check to see if it was 4, and basically we could just kind of go on in that pattern as many times as needed. In this case, when we're doing months, we would need basically 12 nested if-else statements, which you can imagine there's a lot of curly braces in there, a lot of parentheses, a lot of places to mess up. Just saw a place where I wish I'd put in a space. There we go. But it certainly could be done. It certainly could work if we did it that way. But it would be long, it would be messy, and maybe not the best way to get all of this actually put together. So what I could do instead, okay, I could replace that particular set of if-elses with a switch statement instead. The way a switch statement works is you start off with the keyword switch. Right. The keyword switch is followed by a set of parentheses, and inside that parentheses, instead of putting in a Boolean value the way we do with most control flow statements, is we instead simply provide it with a value. So here I'm just giving it my month variable, which of course contains whatever value the user entered. What I do inside the switch then is I provide a series of what are called case statements. So something like in the case that that value is 1, and then I simply here tell it what to do. So I could tell it do a document.writeline for January. Right? After each one of these case sections, we then put in the keyword break, which we'll talk more about later. Right? So what this is literally saying is look at the value of the month variable. In the case where that value is equal to 1, then perform as many actions as I happen to have here until it reaches the break. So I could then go and I could do case 2. Oh, there we go. The case statement, its value is followed by a colon, which is a little bit different than what we've seen before. February, break. Okay. And with a little copying and pasting, I could get this entire thing put together here pretty quick. All right, so we've got 2, 3, 4, 5, 6, 7, 8, 9. That'll be 10, 11, and 12. 10, 11, and 12. Let me just get the right month names filled in. There, something along those lines. So you can see, compared to that if-else that we had before, this is much more streamlined, much neater in the way that it's actually written. It takes a lot less code, a lot less room for mistakes that way, and it should still work just fine. If I come over and pull it up in my browser, it asks me to enter a month. I'll tell it month 4, and it tells me month 4 is April. If I tell it month 10 is October. So you can see it works just fine. Okay. Like I was saying before, okay, it's simply going to look at the value that we provide inside the parentheses after the switch, and it's going to try to match it up against one of these cases. If it finds a case that matches, like 10, for example, it then executes all of the statements that come after the colon and keeps executing statements until it runs into the keyword break, which, like I said, we'll talk more about later. Okay. One other special thing that we can do with a switch is that we can put in a special case as a last case called the default. What the default case does is it matches if nothing else has matches. If nothing else matches. So we could do a document.writeLine here and say, I don't know that month. Right? So if the user enters any number other than 1 through 10, where all of these would be considered to matches, then the default will match instead, and it'll print out I don't know that month. Let's give that a try. Enter month 89. I don't know that month. Enter month 5. That's May. Right? So that all works just fine. It's very streamlined, very concise. It's a nice way to be able to put that particular type of logic together when you're simply trying to match a value that you have available against a series of different possible meanings or possible uses for that value. There is one other neat little thing that can be done with a switch statement that actually has to do with that keyword break. I mentioned to you that whenever a match is found between the value that's supplied to the switch and one of the case values that we provide, what happens is JavaScript executes all the statements that follow the colon until it finds a break. So what actually happens if we leave a break off? Well, if I were to, for example, leave off this break right here, right, then what will happen is if I enter case 7, if I put in 7 for my month, then it will execute the document.writeLine for July, and then because it doesn't run into a break, it will keep executing, and it'll come down and execute the document.writeLine for August as well. Let's go ahead and give that a try. Right? What month? 7? Yeah, July and August. You see both print out because of that missing break. There are some situations where that actually can be a benefit. For example, if we wanted to here, instead of printing out the name of the month, maybe what we want to do is we want to have it print out what season that particular month is a part of. What I might do for starters is I might just reorder my cases here. I'm going to take case 1 and 2, and I'm going to stick them down here at the bottom. So I have all my winter months together, all my fall months, summer, spring, depending on whether you're talking about Oklahoma months or not. Anyway, we'll just say that we have 3 months per season. It makes it nice and clean that way. Right? Now, if I wanted to keep this as sort of a very traditional switch case, what I'd have to do is for all the spring months, I'd have to go in and put in document.writeLine spring. For all the summers, I'd have to go put in document.writeLine summer. And that's kind of a lot of repeated code, and it's really pretty unnecessary in this case. Because what I could actually do is for case 3, case 4, and case 5, I could set them up basically like this, where 3 doesn't have any code, 4 doesn't have any code, but 5 has document.writeLine for spring. And what makes that special is that 5 is the last month in that particular group, and that's the only one that then actually has something to execute in a break. What will actually happen then is if the user enters 3, right, it'll keep executing until it finds a break, which means it will fall down here and end up printing out spring and then stopping. If they enter 4, the same thing, 5, the same thing. So I could set all of my months up basically that way. Right. Fall. And I end up with something that kind of looks like this. So you can see there's quite a bit less repeated code in here now, but everything should still work out pretty much exactly the same way it did before. Let's give it a try. All right, it asked me to enter a month. I'm going to tell it month 2, and it comes out and it tells me winter. So I entered 2, 2 was stored in month, it came through looking for a case, found 2 down here, and of course executed the document.write line after it, followed by a break, so nothing else happened. But if I put in month 3, I get spring. That time it found the match right up here, the very first case, right? There was no break following it, so it kept executing. It eventually came down and executed this document.write line. That document.write line was then followed by a break, which caused the execution to stop. So kind of a nice little clean way of being able to put together that particular pattern. Okay, next up is repetition structures. Repetition structures will let us decide whether a statement or a group of statements gets executed multiple times or not. And just like with selection statements, selection structures, repetition structures are going to be based on some kind of Boolean condition. Repetition structures are usually referred to simply as loops. So here in this diagram, for example, we perform some test. If that test is true, we execute some statement, and then we go back and we perform the test again. If the test is still true, we execute the statement again, and then we go back and check the test a third time. That will basically keep happening over and over and over again. You can, in the diagram there, see the actual little loop until eventually that test becomes false. When the test is false, then we break out of the loop and we go on and we do something else. Kind of like with selection structures, repetition structures in JavaScript can be put together a number of different ways with a number of different keywords and combinations of them. We'll talk about the while statement, the for statement, do while statements, and for in statements, which are all the different ways we can put together repetition structures in JavaScript. So let's go ahead and see an example. Here. For example, while there are numbers remaining, then we take the next number and we add it to the total. We then go back and say if there's more numbers still remaining, then add that one to the total. And we keep doing that over and over and over again until eventually we run out of numbers to add to the total. When that's true, or when it's true that we've run out of numbers, the condition becomes false, and we then go on at that point and display the total. Now let's go take a look at some actual repetition examples. The first of the 3 different looping control structures, repetition structures that I wanted to go over with you, is called the while loop. Basically, the way the while loop works is it starts off with a keyword while. The keyword while is then followed by a set of parentheses, and like with the if statement, what we want inside the parentheses is a Boolean expression, an expression that will evaluate to being either true or false. Following the parentheses, we then have a set of curly braces, again very much like we had with the if statement, and they serve basically the same purpose. The while statement is going to be in control of the thing that immediately follows it. And if what immediately follows it is a block, a set of curly braces, then all of the statements inside those curly braces will be under the control of the while. Whereas if we left the curly braces off, the while would simply control the one statement that immediately follows it. Right? So just to kind of show you what the while loop's going to do here, let me start by creating a variable. I'm going to call it count, and I'm going to set it equal to 0. What I'm going to then do inside the while loop is I'm going to say while count is less than 10. Right? And what I actually want to do inside the while itself is I'm going to do a document.write line where I print out the value of count, followed by a break. Right? And then I'm going to do count plus plus. So more or less what's going to happen here is we start off with a value of count equal to 0, right? The way the while loop is then going to work is that as long as this statement is true, it will continue to execute whatever's inside the loop body, whatever's inside the curly braces here. After each execution of the loop body, it will then come back and recheck the test again. So it starts off with count equal to 0. As long as count is less than 10, it will print out the value of count, and then it will add 1 to count using our increment operator. Right? If we take that and we pull it up in our browser, you can see what ends up happening is it prints out the numbers 0 through 9. If you kind of follow it through, we start off with count at 0. 0 is less than 10, so that's true. So it prints out 0. It then adds 1 to count. So at that point, count becomes 1. It then comes back up and checks to see if count is still less than 10. Well, count is currently 1, so that's still true. So it prints out 1, and then it adds another 1 to count, so count becomes 2. It, of course, prints out 2, 3, 4, 5, 6, 7, 8. After it's printed out 8, right here, it adds 1 to count. Count becomes 9. Comes back to the top of the loop. 9 is less than 10. That's still true, so it prints out 9. It then adds 1 to count, so count becomes 10. At that point, when it comes back to see if count is less than 10, at that point the answer is false. 10 is not less than 10. 10 is equal to 10. So once it finds a false condition here, at that point the while loop is over, and it simply goes down to the last curly brace and continues executing whatever else may remain in the script from that point. So we end up getting 0 through 9 printed out there. Really not much to it, right? With a while loop, or really with any type of loop, something that you always want to be careful of is there's basically 3 things you always want to look for. You always want to make sure that you're initializing some variable so you know where its value starts. You want to make sure that you're testing that variable, and you want to make sure that inside the loop body somewhere you are changing that variable. Those 3 things, which we would usually call initialize, test, and change, are important, because typically if you leave any one of those 3 out, then you're running a good chance of running into what's called an infinite loop. An infinite loop is simply a loop that never ends. For example, if I took out my count plus plus there, you can imagine what would happen in the script is count would start off at 0, count is less than 10, so it would print out count. It would then come back and check. Well, at that point, count is still 0. 0 will always be less than 10, so it will basically print out 0 infinitely. It'll just keep going. Infinite loops in JavaScript aren't quite as severe as they can be in some languages. Usually it's something that the browser will actually catch. Let's actually go and try this and see what happens. Hit refresh in my browser. I've got a little spinning beach ball there. It's thinking really hard. Right? And who knows how long we might have to sit here. Oh, there, that wasn't too bad. So in this case, Safari says Safari is no longer responding because of the script on the web page called this. Do you want to stop the script or let it continue? I do want to stop it, but you'll notice all the zeros that are printed out here, and look at the scroll bar over here on the side. There's a whole lot more zeros that we can't see. So I'm going to go ahead and tell the browser to stop this particular script to get me out of that infinite loop. And of course that could be fixed just by putting my count plus plus back in. Right? I could also, besides doing count plus plus here, you might remember when we talked about pre and post increment and decremented, I could actually put the plus plus on count right there as well, and I would end up with the same result. There we go, 0 through 9. So that's basically the way that a while loop works. They're very, very handy. They can let scripts become very powerful, because with just a few lines of code, you can have a script do a tremendous amount of work. You just have to watch out for them, watch out for infinite loops. And as long as you do that, they are a really wonderful, very handy tool. All right, with the first simple use of a while loop under our belt and hopefully understood, I wanted to also go ahead and point out to you that there are actually 2 fundamental types of loops that can be put together, called determinate and indeterminate loops. Some people also call them counter-controlled or sentinel-controlled loops. What we actually had here in our first example of a while loop was what we would call a determinate loop or a counter-controlled loop. The fact that it's counter-controlled doesn't actually have anything to do with the fact that I named my variable count. I could have called that variable anything I wanted, X or number or Frankfurter or whatever I thought would be a good name for it. What makes this actually a counter-controlled loop, a determinate loop, is simply the fact that you can look at it and you can determine basically at the time that you write it, or when you're looking at the code, how many times it's going to execute. I can see that count starts at 0. As long as count is less than 10, we print count and we add 1 to it each time. So I can tell that first time and every time that this page is run, that loop is going to run exactly 10 times. So that's a counter-controlled loop, and those certainly do come in handy, but there is the other type of loop, an indeterminate loop. An indeterminate loop would be a loop where you don't, at the time you're writing the script, actually know how many times the loop is going to execute, how many times the loop will loop, you might say. So let's do another example here and put together an indeterminate loop. Okay? We could do something along the lines of let's let the user enter a value. I'll make a variable v. Oops, some script tags would help, wouldn't they? There we go. I'm going to make a variable v, right? And I'm going to prompt the user. I'm going to say enter 9 to stop. Right? Then I'm going to have a while loop, and I'm going to say while v is not equal to 9, then set the value of v again by prompting the user. And again, I'll say enter 9 to stop. Something like that. Maybe down after that's all done, I'll do a document.writeLine that says done. Right? So in this particular case, how many times this loop actually executes is going to be entirely up to the user. They may enter the magic stopping number 9 the very first time, or they might go through this loop 1,000 times before they eventually enter the number 9. So the user will enter a number. That number will be stored in v. As long as that value is not equal to 9, then we'll ask them again, enter 9 to stop. Okay, that value again gets stored in v, and we go back and we check to see if the last number they entered was 9 or not. So the logic is still pretty much the same, and you'll notice all three of the things I mentioned to you before that prevent infinite loops are all still here. I'm still initializing a variable, I'm still testing that variable, and I'm still providing a way inside the loop for that variable's value to change. Right? So let me take this into the browser and see how it works. If I enter 9 the very first time, it stops immediately. If I enter other numbers though, 1, 2, 3, 4, 5, 6, 7, 8, 0, oops, I didn't hit 0, I hit 9. Once I hit 9, you can see it stops. So this is just a simple example of an indeterminate or a sentinel controlled loop. Okay? It's that type of loop because we don't know how many times it's going to execute. The name sentinel controlled, by the way, comes from the fact that this sort of magic value that we're looking for, that we're trying to match to determine when to stop, that is sometimes called a sentinel value. So those are the two basic types of loops, and they can actually be put together with a number of different looping structures here in JavaScript, but you'll use the while loop most often, especially when you're putting together indeterminate loops. With our newfound knowledge of while loops, something that becomes possible at this point would actually be for us to go back and redo our guessing game so that a user is asked multiple times to guess the secret number. More or less, they are kind of, in a way, forced to guess the secret number, in that they won't be able to get out of the loop until the correct number has actually been put in. If I actually wanted to implement this, one of the first changes I would make is I'm going to create a guess variable and initialize it to a known value, maybe -1 for example, which means down here on the prompt where I was actually getting the value for guess, I no longer need the var that's in front of it. What I'm now going to do is I'm going to put a while loop that basically goes around this entire thing, and what I'm going to have as the condition that determines whether the while loop continues or not is I'm going to say while the guess is not equal to secret. Since I started guess off at -1 and secret off at 9, I know that initially that will not be true. Guess will not initially be equal to secret. Right? I'm just going through and putting my curly braces around everything else I had in the script there. Right? The next thing I'm going to do is I should be able to, at this point, get rid of this outer if statement, and I'm going to take the you guessed it line, the you guessed it document.writeLine, and I'm going to move it outside the while loop, below it basically. Let's see, I've got one extra curly brace still right there. I can take all of this and just clean up my formatting there a little bit. So more or less the way it's going to work now is when the user first visits the page, we declare secret and guess. Secret and guess are not initially equal to one another, which means it's true that they're not equal to one another. So what will happen is inside the while loop, we'll ask the user, guess the secret number. We'll then check to see if guess is greater than secret. If it is, then we'll say you guessed too high. What we now want to do down here is we want to say if guess is not greater than secret, then check to see if guess is less than secret. Right? If it is, then we will print out you guessed too low. Right? If any of those two things happen, they don't guess the number correctly, instead it's either too high or too low, we'll get the correct message that prints out here. We'll then hit the bottom of the loop. Okay? We'll go back to the top of the loop and we'll do the test again. We'll check to see is guess equal to secret. If it is still not equal to secret, then they will be asked to guess a secret number again. And if the number was too high or too low, they'll again get the message and then back up to the top again. Eventually what will happen, hopefully, is that the user will guess the correct number. When they guess the correct number, the guess will not be greater than or less than secret, so we won't get either of those messages printed out. Instead, when we go back to the top of the while loop, we'll find that it's no longer true that guess is not equal to secret, which means at that point we will drop out of the while loop, coming down here to the last curly brace, and then we will print out "you guessed it." So let's see how that works. Let me pull it up in my browser here. Here we go. All right. So guess the secret number. 3. Should have printed out, I guess, too low. Didn't see that. Let's try printing out 89. Should have printed out "you guessed too high." If I print out 9, oh, there's my too low and too high messages. They just never had a chance to actually become a part of the page. But that is the basic idea. Right? What I could probably do to clean that up a little bit is maybe in here, instead of using document.writelines, if I used alerts instead, that would blend a little bit better with the way everything else in the script is actually working, something like that. So let me give that a try. If I guess 78, you guess too high. If I guess 3, too low. If I guess 9, you guessed it. So there we go. The script runs over and over again without me having to hit refresh, and keeps going until eventually I guess the correct number. At this point, we could actually, like I was talking about before, instead of using a fixed random number like like 9, we could instead come up with actually a random number. What I could do is, JavaScript has the ability to do RANDOM, a thing called math.random, which will give me back a random number that's somewhere between 0 and 1. So it's basically sort of a fractional number somewhere between 0 and 1 with a decimal point in it. I could take that random value and I could then maybe take it and multiply it by, let's say, 100. And then on that I could do a, let's see, I could do maybe something like a modulus 10, which will pull it down into the 0 to 9 range. Right? Some parentheses around that to make sure it all works. And then just to be safe, maybe what I'll do is I'll also take that and do a parse int on it. Let's put an alert in here where we actually print out what the secret number is, so we can make sure it's coming out in the correct range, and run that in the browser and see how it works. So here my random number is 6. If I guess 2, too low. If I guess 9, too high. 5's too low. 7, too high. 6, you guessed it. Run it again. This time my random number is 8. If I guess 8, you guessed it. So I don't really need this alert in there anymore. I know that my numbers are coming out basically like I want, and I have a game suitable for entertaining small children for probably, I don't know, 3-4 minutes at the least, or maybe at the most. But anyway, there's another use of a while loop. You'll notice that in this particular case, this while loop is indeterminate. We do not know how many times the loop is actually going to go. It all, of course, depends on the guessing prowess of whoever's playing the game. And like all loops, we have initialized a value, we have tested that value, and then we have provided a way for that value to be changed inside the loop to help make sure that this does not become an infinite loop. The next type of loop I thought we should take a look at is actually a variation on the while loop called a do while. Before we actually go to the do while, though, let me show you this little example that I've put together here that just uses a regular while loop. Basically what it does is it starts off by simply prompting the user to enter a number. Whatever value the user entered gets stored in a variable called input. Then I have a while loop, and what the while loop here is actually doing is checking the value of that input variable by feeding it into a built-in JavaScript function called isNaN, where NaN stands for not a number. This isNaN function will return true if the value that it's passed is not a number. If the value that's passed to it is a number, the isNaN function will return false. So if up here the user types in Bob, then we pass Bob to the isNaN function. isNaN will return true, meaning yes, it's true, that's not a number. So since that would be true, the while loop would run, meaning that we would then, causing the statement to then execute. So we would again prompt the user, enter a number. So I guess in a way this little script is just checking the user's ability to be able to follow instructions. Eventually, the user will put in an actual number, like 3 for example. When we pass the value 3, some numeric value to isNaN, it will return false because that number is a number. It's not a number. So once that comes back false, the while loop will stop, and down at the bottom it'll print out good job. So if we actually run that in the browser, it says enter a number. If I put in a bunch of letters, isNaN returns true. That's not a number. Bunch of letters, true, not a number. But if I put in 8, it is a number, so the loop stops and we print out good job. Anyway, the reason that I wanted to put this together and show it to you before we talk about the do while is because the do while is sort of a variation on the while loop that helps out in certain situations. Some people like it, some people don't like it that much. In all honesty, I wouldn't say I use it very much at all in JavaScript, but it doesn't hurt to know you might run into a situation where it's just the thing you're looking for. But anyway, in what we have here now, you'll notice that we basically have this prompt in here 2 times. I have it once before the while loop and then another time inside the while loop. The one before the while loop would usually be called a priming read. It's basically getting an initial value for us so we know whether we need to go into the loop at all in the first place. The one inside then would be the actual prompt where we're getting the values from the user. What we could do with a do while loop is it would actually let us reduce this down to just having that prompt statement in there one time. What I'm going to do is I'm going to keep my declaration of the input variable, but I'm going to declare it and assign it a value of some string. I don't know, some string. Can't think of anything better to put in there. I guess maybe I could just do an empty string, maybe something like that. Right? Then the way the do while loop actually works is the do while loop starts off with the keyword do, followed by a set of curly braces, and then the while actually goes at the end. Now, the way that the do while loop is different than the regular while loop is that a traditional while loop always performs the test first, and then if the test is true, executes the loop body. With a do while, what happens is it first executes the loop body, and then it performs the test. If the test is true, it'll then execute the loop body again. So this actually lets us more or less combine the actual prompt and the priming prompt together in just inside the body of the do while loop. So the program starts off, creates the input variable, then we prompt the user, enter a number, right? Then we check to see if the number they entered is not a number. If it is not a number, then we come back and we make them do it again. So it kind of simplifies that program down a little bit. If I run it in my browser, if I put in letters, names, anything that's not a number, it keeps making me do it over and over again. But eventually, if I actually do put in a number, the loop stops and we get our message that prints out after the loop is done. So that's really all there is to the do while. It's not by any stretch of the imagination the most complicated or the most used control structure in JavaScript, but every once in a while when you have just that sort of situation, you'll recognize it when you have the same prompt in your program 2 times, or the same something like a prompt in your program 2 times, then that's a situation that a do while loop can potentially help simplify. The last of the 3 looping control flow structures that I want to show you now is called a for loop. The for loop, used in this particular way, we'll find that there's actually a couple of variations in it. This particular for loop is basically one that is very good for doing counter-controlled repetition. Whenever you have a loop that you want to run a specific number of times, a for loop a lot of times is the quickest, easiest way to actually get that put down in code. It looks a little bit complicated, but once I show it to you, I think you'll see that it's actually pretty handy. More or less the way that a for loop works is you start off inside the parentheses following the keyword for by declaring a variable and initializing it. So var count or something like that, for example. That is then followed by a semicolon. Right? The next thing we then put in is a test, so something like count less than 10. That's then followed by a semicolon, and then the very last thing we put in is some way of changing that variable. More or less what we're doing here is we're taking the three different things that I've mentioned to you previously as being important to avoid infinite loops, and the for loop actually lets us put all three of those things right there inside the parentheses. So I have the declaration and initialization of a variable, the testing of that variable, and the changing of that variable all together right there in the for loop syntax. Here inside the body of the for loop, what I'll do is I'll just print out the value of count followed by a break, sort of like we did before with our while example. If I pull this up in my browser and we run it, you can see we get 0 through 9, very much like we did before in the while example. The only real difference here with the for loop is simply the syntax of it. The way it's put together is a little bit different. The way the for loop actually runs is when the for loop is first executed, okay, the very first piece inside the for loop's parentheses is executed, which creates the count variable and initializes it to 0. The next thing that happens is it performs the test. If the test is true, then the next thing that happens is it comes down and it executes the loop body, whatever or however many statements happen to be inside the curly braces. After the loop body is executed, it then comes up and executes the change, the last of the three parts inside the for's parentheses. After it executes the change, it then goes back and does the test again. If the test is still true, it executes the loop body, then it executes the change, then it executes the test. If the test is true, it executes the loop body, and keeps going like that until eventually, of course, the test becomes false. Once the test is false, the control of the program goes to the closing curly brace with the for loop, and then on from there. Maybe I'll throw one more document.write line down there saying we're all done. Let me fix that little E there, something like that. So that's what we actually end up with. There's really not much more to it than that. That's really just kind of what for loops do. They're just perfect for when you're wanting to do counter-controlled repetition. Any of the three sections that we can put up here in the for loop can also be left out. I could, for example, if for whatever reason the situation necessitated it, I could declare my variable before the for loop and then just leave the declaration and initialization section of the for loop empty. I could, if I wanted to, actually remove the change section, maybe put it inside the loop, something like this. Now there's really, in my opinion, absolutely no reason to write a for loop like this, because of course what we essentially have at that point is a while loop that we had to put a couple of extra semicolons inside the parentheses. So why bother writing a for loop like this when while loops are available? But I just wanted to mention to you that that kind of thing is possible. You can actually leave any of those sections blank if you happen to need to. That is, of course, with the exception of the test. The test does certainly need to be there. Let's take a look at an example where we can bring some of these different types of loops together that we've been playing with. What I want to do here is I want to write a program sort of very much like one that we've actually written previously. More or less what I want to do is I want to allow the user to enter a series of numbers, and then I'm going to want the JavaScript to go through and find the average of all of the numbers that the user entered. We wrote a program like that before, and it was actually a very good way of doing it. It was very short and concise, kind of pretty in a way. If you're to the point yet where you can start to find code pretty, then good job. But here I'm going to do it just in a different way. It'll be longer, maybe a little bit more obtuse, but it'll give us a chance to use some of our different loops that we've been discussing. For starters, the first thing that I want this script to do is I want it to let the user enter a series of numbers, one per prompt this time. So more or less what I want to do is I want to do an indeterminate loop where the user gets to keep entering numbers. Each time they enter a number, I'm going to take that number and store it in an array. So maybe what I'll do here at the very beginning is I'll create an array. I'm going to call it nums. I'm just going to say it's a new array. That. So I have my array ready to go, ready to hold as many numbers as I might happen to need. Right? And what I'm going to do next then is set up an indeterminate loop. I think maybe I'll create another variable up here. Maybe I'll call it input, and maybe I'll set it to -1, for example. Right? Then I'm going to say while input is not equal to what do we want our sentinel value to be? Let's say -1. While input is not equal to -1, or even better, why don't we use a string? While input is not equal to the word stop. let's say, for example. Then what I'm going to want it to do is I'm going to want it to keep asking the user to enter values, numbers. Each one will then be added to our array. So input starts off at -1. That's certainly not equal to stop. So let's prompt the user. Let's say input equals prompt, enter a number. There we go. The user will then actually enter that number, and we want to then take that number and put it into our array. There's a few different ways that we could actually do that. We could, for example, say nums some element is assigned the value from input. The trick with that, doing it that way, is trying to figure out what to put here for which element to put it in. And what I could actually do is I could do nums.length right there. Basically the way it works is when the array is first created, its length is 0, so the very first input will be put into element 0. After that first value has been put into element 0, the length of the array is then 1, so the next input would be put into element 1. That would work out just fine. We certainly could do it that way. Something that would be a little bit cleaner, though, is there is a function available for arrays called the push function. The push function simply takes a value and pushes it onto the array, kind of like adding a dish to a stack of dishes is more or less sort of the idea. So that would push that value in there. All right. So what we have so far is we have our array, we have a declaration initialization of our input variable. As long as input is not equal to stop. Oh, and I should probably add that to my prompt here. I'll say enter stop to quit. All right. As long as input's not equal to stop, then what we'll do is we will prompt them for the value, right? We will then take that value and push it into the array, right? We'll then come back up and check to see if that value is stop or not. Now, the way that's actually written right now, we're going to have a little bit of a problem there. If you think about it, what will happen is if the user enters stop, stop will actually get added to our array before we come back up and realize that it's actually time to stop. So what maybe we should do is we should start by prompting the user before the while loop, right? So that inside the while loop we can then do things in this order. We could first ask them, enter your number, right? We then check to see if the number they entered stop. As long as it's not, we can push that value onto the array, and then we can ask them again. So here, if they actually do enter stop, the very next thing that will happen is we'll realize that it's time to stop, and that word stop will never actually get added to the array. Here, of course, though, is that situation I was telling you about before, where we have the input in here basically twice. So if I were to take this and turn it into a do while, that would probably simplify things just a little bit, but it would also complicate them a bit because I have this push in here, and I don't want to push any initial setting value like my -1 up here onto my array. So I think I'm actually going to leave this just the way it is right now. I think just for debugging purposes, what I'm going to do is I'm going to just ask it to print out my nums array, and let's go ahead and run it the way it is and see what's happening. So enter a number, enter stop to quit. So I'm going to put in 1, 2, 3, 4, 5, and then I'm going to type stop. And there's the array that got built, 1, 2, 3, 4, and 5, all stored there in my array. So it looks like everything's working out just fine so far. Right? Once that part's done and we're able to collect the initial input from the user, the next thing I want to do is I want to go through and find the average of all of those different values. To find the average, I have to first find the total. So let me start by creating a total variable, and I'm going to initialize it to 0. And then here what I need to do is I actually need to go through the array and total up, basically accumulate together all of the different values that are in the array. Arrays you're going to find and for loops tend to go together just perfectly, like bread and butter. What I could do here is I could put together a for loop where I create maybe a variable, I'll just call it x, and I'll say while x is less than the length of my number array, x++. So I'm starting x off at 0, which means we'll start at the very first element of the array, and I'm saying keep going until we get to the end of the array, essentially. If you think about the way arrays work, where they start at 0, the length of an array is always one less than, the length of the array is always one greater than the last index number. So saying x less than nums.length is just perfect, and then x++ simply means we'll be going through each and every element one at a time. Right? So I've got my total variable there already. What I can do then is I can say total plus equals. I'm going to take the values from our array and make sure that they get turned into integers. So my array is called nums, and I'm going to take element x. So each one of the individual values as we come to it, based on the current value of x, will be turned into an integer and will then be added to our total. So by the time that's all done, we should have a total accumulation of all those numbers. So again, I'm going to throw an alert in here and run the script over in my browser just to see if everything's working the way it should. So in the browser, I'm going to enter 1, 1, 1. Then I'm going to tell it to stop. So our total should be 3. And sure enough, 3 is exactly what we got. So things are going well. The last thing the script would need to do then is it would need to, of course, do a little division to find the actual average and then print out that average for the user. So I'm going to create a new variable. I'll call it AVG. Right? To get that average, I'm going to take the total and I'm going to divide it by the number of numbers that were entered, which is the same as the length of the array. Right? That should give us our average. Then we can just do a document.writeLine. Okay? Print out the average is, and I'll print out AVG, and let's see what we get. All right, if I enter 1, 1, 1, the average should be 1. Oops, I forgot to enter stop. That's going to mess everything up because I got that extra blank in there. Maybe that's something I should go back and fix. Let me try it again. 1, 1, 1. I'll type in stop. There we go. The average is 1. If I put in 1, 2, 3, 4, 5, and then stop, the average is 3. So it looks like it's doing well. I guess the only problem I ran into was that time I hit the enter key once on accident instead of typing stop. That actually ended up putting a blank into my array right up here, which wasn't something that I actually wanted. That could maybe be something that we could fix with an if statement. I could do something like, say, if the input, if it is not a number. Boy, there's some nasty double negative logic for you. Right? Then push it into the array. So input, of course, is the value the user entered, and I'm saying if it's not a number, right? But then I'm also throwing this exclamation on the point, which means not. So I'm really, in essence, saying not a number, which combined together means is a number. So if the input is a number, push it into the array, otherwise we'll just prompt the user again. Let's see if that works. Let's put in 1, 1, 1. Then I'm going to hit the enter key 1, 2, 3, 4, 5 times. And then let me type stop. Oh, and we still ended up with not a number in there. So something's certainly not working. Maybe what I need to do here is I need to throw in an alert and see what's actually getting into my array. Let's try that again. 1, 1, 1. Enter, enter, enter. Stop. Oh, it looks like those spaces are still getting in there somehow. Maybe I outdid myself with my double negative logic there. Let's see. If the value is not a number, not a number, then push it. But it seems like it's getting pushed in anyway. Let me try adding another alert in here. And let's put in here pushing, and let's put in the actual value that's getting pushed in so we can see it actually happening. 1, it's pushing 1, 1, pushing 1, enter. Yep, it's pushing the blank. So for some reason my if statement there doesn't seem to be doing just what I want it to do. That's kind of peculiar because it sure seems like it makes sense to me. It's pushing everything in, both numbers and not numbers. Curious. Well, there's another way we could go about this. There's always another way. I could say if input is not equal to a blank, an empty string, something like that, then push it. So let's see how that works. 1, that got pushed. A space, that didn't get pushed. If I hit enter now, things aren't going in. 2 got pushed. 3 got pushed. Blanks aren't getting pushed. If I do stop, that's what I end up with in my array. My average comes out 2. I'll have to think a little bit about why my is not a number didn't work, but often you'll find that if one thing doesn't work, trying to come about it from a different angle can at least get you past that step, and then you can always come back and meditate later on how to do it the way you'd originally intended, or figure out why it was that way didn't work. So there you go. There's an example that uses some of our different control structures. We have our while loop in there. We have an if statement. We have a for loop. Okay? Most of them are fairly interchangeable. There's lots of different ways we could have put this together, but you can see that with those we can put together just all kinds of logic and get all kinds of work done, pretty much whatever we might happen to need. The next control structure we can talk about then is a variation on the for loop that we discussed just a minute ago, called this one is called the for in loop. It's kind of funny. I'm not exactly always sure exactly how to categorize it or where to place it. It is technically, I guess, a repetition structure, a loop of a type, but it's so special purpose that I really sort of want to put it into the special category. One way or another, what the for in loop really has to do with is objects. All it's really good for is working with objects. There just really isn't much else that it actually does other than work with objects and the values that are stored inside them. So for the for in loop to do anything for us, we really need an object. So let me create an object literal here. I'm going to create a variable called person, and into it I'm going to put an object literal. The object literal is going to have, let's say, values. Let's do first name, where I'll put in the value Victrola. Let's put in a last name property with the value of firecracker. Okay, and then that will be our object literal. Now, just to refresh you, you might remember that of course we can at this point do something like person.firstname, and that will access the first name value that's inside the object called person. If I go and pull this up in my browser then, here it is. There we go. There's the first name. Now you might also remember that we could treat an object like it was an array, and we could use this syntax, subscript notation it's called. Again, I'm just asking for the value of the first name property that's inside the person variable, and again in the browser I still get Victrola. So what we can do now with a for in loop is the way the syntax works is it starts off more or less just like a regular for loop, but inside the parentheses we're not going to have the 3 sections like we had in there previously. Instead, what we're going to do is first thing inside the parentheses of the for loop is we're going to make up a variable. I'm going to call it attr, short for attribute. You then follow that with the keyword in. That's then followed by the name of an actual object. So you can see here why they call it a for in loop, for and in, right? If inside the loop here, inside the for in loop's body, what I'm going to do is I'm going to print out the value of our variable attr followed by a break. And if I pull that up in the browser, you can see what it actually does is it goes through the object, kind of picks the object apart. Right? As it loops through the object, it takes each one of the object's attribute names and puts the name of that attribute here into the variable that we supplied. So here when I ask it to print out the attribute names, it printed out first name and it printed out last name, the actual 2 attribute names of that exist inside the object that I'm feeding to the for in loop. Right? Another thing that we could then do with it is, since we have that array syntax notation, if I take that attribute name and use it in conjunction with the name of the object, I can then also use the for in loop to get at the actual values. Oops, or at least I should be able to. Oh, I see what I did. There we go. We don't want to put the quotes around the variable name, because then of course the attribute that we're actually asking for is attr, and there's nothing called attr inside person. So there we go, Victrola and firecracker. Outthought myself again. Okay, so that's pretty much really all the for in loop does, is it's just sort of a handy little loop on occasion when you need to actually pick through or deal with all of the different attributes that are available inside any particular object. So like I mentioned before, it's very special purpose. It's not a general loop of any sort. I'm not even really sure whether we would call it determinate or indeterminate. It just doesn't really kind of fit the mold of any of the other repetition structures we've talked about. But there it is, and maybe someday you'll find a good use for it. The very last type of structure in JavaScript is what I'm going to call a special structure, or in the special category. It's called a with structure or a with statement, and it really doesn't bear any resemblance to much of anything else. So let's just look at it now all by itself. The last control structure I want to go over with you is a control structure called with. It's actually the word with followed by parentheses and curly braces. So the structure of writing it's very much like what we've done before. But with what the with control structure does is really unlike anything else. I, in some ways, even sort of hesitate to call it a control structure. A bit like the for in structure, what with actually does is it deals with objects specifically. What you can do with it is you can put the name of an object here inside the parentheses. Any statements that then come inside the body of the with will be, if they can't be executed kind of on their own, then JavaScript will attempt to execute them by appending the name of the object, in this case document, in front of it. So normally, of course, I would need to type document.writeLine to print something out to the page, to output it in as page content. But with the with document that I've got here, what I could do is I could just do writeLine, right? Hello, for example. And if I pull that up in my browser, you can see that it actually executes just fine. So what happened here was JavaScript would actually try to execute this statement kind of on its own. It would recognize that it didn't know what the writeLine function was, so it would then go back and try executing the writeLine function as if it had document dot in front of it, and that would then allow it to execute. This again is a control structure that I don't use too terribly often, but sometimes if you're doing a lot of work with one particular object, it can save you a little bit of code to take all of the different statements that deal with that one particular object and put them all inside a with statement, all inside a with structure, kind of like I have here. So another one that sometimes comes in handy, but certainly not one you ever have to use. The last subject that I want to cover in this episode is the use of the keywords break and continue. We've actually seen the break keyword used when we did a switch statement. There's something that's pretty much necessary anytime you're doing a switch statement. But break and continue are both keywords that can also be used just in their own right. I have to, of course, add here that I don't actually recommend that they be used, at least not by any routine. But every once in a while you might find a legitimate use for them. You just have to be careful. They're something that certainly can be abused, and I've been in plenty of programming classes where the instructors have threatened to fail anybody who turned in code that had the keywords break or continue used in them. I'm certainly not one of those instructors. I'm a bit more pragmatic than that. I say if they help and make the script shorter to write, easier to understand, then there's certainly nothing fundamentally wrong with them. But just be warned that some people think that they are basically evil, I guess is what it comes down to. What I actually have here in the script so far is I have a for loop that goes through and simply prints out the numbers 0 through 9. I then have a document.writeLine that prints out a horizontal rule, so we'll get a horizontal line separating one piece of output from another. And then I have another for loop that goes through and prints out the numbers 0 through 9, and then a document.writeLine at the end that says we're all done. So in essence, it's just a modified version of one of the for examples that we had done previously. Okay, so what you can see we actually end up with here in the browser is the number 0 through 9 printed, followed by a horizontal rule, followed by the number 0 through 9 again, and then the message, we're all done. Now what I want to actually do with this is I want to go and put the break and continue keywords in here. What I'm going to do here inside my first for loop is I'm going to say if the count variable is equal to 5, then break. This will let us actually kind of see the effect that a break is going to have. If we take and we pull that up in the browser, you can see that what's happening now is instead of 0 through 9 being printed, we're only getting 0 through 4. What happened to the 5 through 9? Well, that's where the break actually comes in. What happened here, of course, was we started off with count equal to 0, count was less than 10, so we came down to execute the loop body. We checked to see if count was equal to 5. It was not, so we printed out the 0. We then came back up, we added 1 to count, so count became 1. 1 is less than 10, so we executed the loop body again. Count was not equal to 5 again, so we just printed out the value of 1. Now what of course eventually happens is we increment count, making count become 5. When 5 is the value of count, count is less than 10, count is equal to 5, so at that point, when count is equal to 5, we execute the break. Whenever a break is executed, what it literally does is it breaks the loop. It causes the loop to execute no more. So once we execute the break here, the control of the program immediately goes down to the very end of the loop, the very last curly brace, and then goes on from there. So we actually in that case ended up with 0 through 4 being printed. 5 was never printed because when the value of count was 5, we broke the loop and we went on and printed out the horizontal rule and then went on with the second loop. So 0 through 4 followed by the horizontal rule is what we ended up with. Right? What I want to do here then inside the second for loop is very similar. I'm again going to say if count is equal to 5. What I want to do in this case though is I want to put in the keyword continue, if I can spell it anyway. Which I can't. There we go. Now I got the keyword continue spelled. Spelling's always the biggest challenge for me. Right? What we're going to find is that the keyword continue is actually similar to break, although it is a little bit different. If I put in that little bit of code and we come over and we look at the output again, you'll see that we're still getting 0 through 9, but if you look closely, you'll notice that 5 is missing. What happens with the keyword continue is whenever continue executes, we go back to the top of the loop immediately. So just like in the previous loop, we print out 0 through 4. Once we increment count and count becomes 5. Okay? 5 is less than 10, so we execute the loop body. If count is equal to 5, then we execute the continue. As soon as we execute the continue, we forget about the rest of the loop body. We instead immediately come back up and start the loop over again, adding 1 to count, so count becomes 6. 6 is less than 10, it's not equal to 5, so we print out 6. So we end up with 0, 1, 2, 3, 4, and then 6, 7, 8, and 9 as our actual output. 0, 1, 2, 3, 4, 6, 7, 8, and 9. 5 is left out. So like I said before, break and continue aren't things that you'll probably use too terribly often. Break, of course, you will use whenever you use a switch statement. But other than that, you probably won't use these two very much. You might, however, occasionally run into a situation where they might save a lot of processing, maybe save a little bit of coding, in which case I say by all means use them. Other people disagree with me on that and say don't ever use them no matter what. But better informed than not informed. If nothing else, you may someday see these used in somebody else's code, so it's good that you at least understand what it is that they do.